Water and Wastewater Engineering, KNS 3233. The given project is sludge treatment and disposal. Our group members consist of Chu, Eric Tiong, Ernest Yi, Louis Yet, and Jackie Cheng. Introduction. The project title is a new sewage treatment plant of Samarian Petrajaya Kuching Sarawak. The proposed project shall be referred throughout the Environmental Impact Assessment (EIA) report. The project area covers 4.8 acres or 19411 meters square. It is designed to treat domestic wastewater for population equivalent PE capacities of 15513.35 PE. It should be compared to Standard A of Environmental Quality Act. Next is a legal requirement of project. The Environmental Quality Act (EQA) of 1974 has been adopted as Malaysia's principal law instrument for environmental management. The Environmental Impact Assessment (EIA) report is required under the EQA 1974 Act 127. Environmental Impact Assessment (EIA) is a legal requirement in Malaysia, and this sewage treatment plant development falls under the category of prescribed operation that must be submitted to the Director General of the Department of Environment (DOE) for permission. The EIA report was prepared by a qualified person registered with the DOE and was based on the DOE News Environmental Impact Assessment (EIA) criteria. The EIA guidelines in Malaysia were produced to help in understanding the objective of EIA, the technique for conducting EIA studies, and the guidelines for writing EIA reports. It also includes provisions for including methods to prevent, lessen, or control undesirable environmental impacts, as well as a more detailed description of each stage of the proposed prescribed activities during its design, construction, and operation. Objective and scope of project. The purpose of the project is to convey the findings of the EIA report that was conducted to achieve the following objective: to present project needs and justification, to describe the existing environmental conditions surrounding the proposed site, to describe the sewage water treatment STP technology and layout design, as well as the wastewater treatment process, to describe the key activities involved in the sewage treatment plant's operation phase, to identify and assess the potential environmental implications that the sewage treatment plant's operations could have, to recommend appropriate pollution control and mitigation methods to reduce potential consequences during the sewage treatment plant's operation period, to explain the conclusion and recommendation of sewage treatment plant STP project. Statement of need. The population equivalent PE calculation for a new sewage treatment plant STP has been proposed to be around 15513.35 PE. Hence, development of a sewage treatment plant with a very high efficiency is required. Within the new STP boundaries, the STP is designed to remove pollutants from wastewater and generate ecologically clean water through physical, chemical, and biological methods before being used on land. A standard aeration activated sludge system as the new sewage treatment plant STP. The design, calculation, and plans has been designed and complying with the guidelines of Malaysian Sewage Industry Guidelines (MSIG) Volume 3 and 4 issued by National Water Services Commission (SPAN). The final discharge from STP should meet Standard A of the Environmental Quality Sewage Regulations 2009 as required by DOE. Project justification. The location of the project is in a sub-development area that will undoubtedly have beneficial implications on population expansion, economic prospects, and future demand for residential, commercial, and industrial properties. This development is expected to result in the creation of better infrastructure, including new road connections and social amenities, that would immediately improve the quality of life for the existing regional community. As a result, a new sewage treatment plant (STP) has been planned to meet the demand as an economic development region experiencing rapid growth and rapid expansion of residential, commercial, and industrial properties that will generate sewage on a daily basis. The new sewage treatment plant is designed to remove contaminants from wastewater and home sewage water, allowing it to be reused. In It is not only safe water by allowing it to be reused, but it also reduces the environmental damage caused by wastewater discharged directly into the environment.
Now we move on to the site options. For this site, which we decide to choose the area that consists of residential, commercial, and industrial. And some criteria that we need to consider is environmental accessibility, social and economic value, social impacts and contribution to the economy, land use compatibility, and relevance to government policies and development strategies. Next, we move on to the site selection ability. Uh, the site that we choose has the large quantum of sewage, which contain 15,513 PE for the Samarian area. It encompasses a 3 km radius zone from the project boundary. Uh, the site is an ongoing mixed-use development that will include residential, commercial, light industrial, and public facilities in the future. So it is necessary to provide centralized FTP. Next, we move on to the technology options. According to Indawater in 2021, in Malaysia, primary treatment systems such as public septic tanks and in-home tanks are unreliable. Low-cost secondary treatment systems such as oxidation tanks are widely used. The in-home tank is a simple sewage treatment plant that requires very little operational skill. There is no mechanical equipment maintenance required. And move on to the oxidation ponds. It also called stabilization ponds. It is a popular wastewater treatment method in small communities due to their low construction and operating costs. And then we move on to the package, or we can call it mechanical sewage treatment plants. It is often used to serve the communities up to population equivalent of 5,000. Next, we move on to the project options. In this project, we are choosing the EAAS, which is Extended Aerated Activation Sludge System for this new sewage treatment plant. Uh, it is because EAAS system has advantage that sludge has a longer life and higher durability, making the process stable and easy to operate.
Now we'll move to the project description and components. First of all, it's about the project location. The proposed sewage treatment plant is located at Samarian Kuching, Sarawak, as shown in the figure here, and then it is constructed on the empty ground and near a river called Batan Salat. And then it is placed roughly 3.6 km from the heavy residential and commercial areas, and then its size cover on 4.8 acres or 90,411 meters square of land.
For this part, I'm going to talk about the population equivalent PE. So as shown in the figure above, we have distributed the site into two parts, which is site 1, the red one, and the blue one, site 2. And the site 1 is the ongoing development area, while the site 2 is the existing area. So this table shows the detailed calculation of total PE for site 1. As you can see from table, site 1 is having a total PE of about 1.3K. Then this is the table showing the total PE for site 2. From the table, the site 2 is having a total PE of about 14.2K. Site 1 is having area of about 31 acres, while for site 2 it has area of about 307.52 acres. Based on the two tables above, the total population equivalent for the site area that has been covered by the new proposed sewage treatment plant is about 15.5 K. The value of total population equivalent is said to be acceptable, as it is within the range set, which is between 15K to 20K. Thus, a new proposed sewage treatment plant will be designed to cover a population of 15.5K within the total area of 338.52 acres.
Now I will explain about the process description of the proposed sewage treatment plant. The sewage treatment plant operates with mechanical treatment system with 5 principal processes. Figure here illustrates the sewage treatment operation flow. As can be seen from the figure, the sewage treatment plant consists of 3 main treatment processes, which are preliminary, primary, and secondary treatments. The first step of the treatment process is screening. The raw sewage first goes through the screening process, where more sizable waste solids are separated from the sewage to avoid destruction to the following equipment. The following process is grit removal, which is a gravity separation technique of microparticles with a specific gravity higher than organic matter to minimize blockage from grit deposition in channels. Next is the primary clarification, which is known as the sedimentation process, where the flow velocity is lower, sludge will produce and settle down at the bottom of the tank. Also, scums will develop and float on the sewage surface. Both the sludge and scums form are removed for disposal. Then is the secondary treatment, which is often referred to as biological treatment. The technique of the activated sludge process is employed by which oxygen is supplied to remove biodegradable organic substances. The activated sludge process requires both the aeration and secondary clarification. The aeration process helps to mix the oxygen supply with sewage adequately. Then the function of secondary clarification is similar to primary clarification, but the waste product form is known as activated sludge. The return sludge pump will convey a portion of this activated sludge to the aeration process to enhance bacterial concentration. Then the excess is discarded for sludge treatment. After that, the effluent is disinfected with chlorine and eventually can discharge into the waterways.
I'm Jackie. So for this part, I'm going to talk about the existing environment. The first is the physical chemical environment. There are many parts under the physical chemical environment, where the first is the land use. From the satellite image shown in the slide, the nearest location found is the Freshmark, which is 0.9 km far apart, where it is far enough from the residential area and will not cause serious pollution. The residential area and commercial area starts to appear started from 1 to 2 km radius. So for this figure, it shows the hydrology map. Our proposed STP is constructed on an empty ground near a river called Batang Salak. This figure shows the river flow and the stream flow for the proposed site. The next part is the topography part. The entire proposed site can be subdivided into slope steepness categories. For our proposed STP, it used a land area of 4.8 acres. All of the land area is categorized under class 1, which is 0 to 5 degree slope steepness class, which it can be said it is gently to moderately sloping. This figure shows the elevation of the proposed STP, which we get from the Google Earth Pro. From the figure, the minimum elevation is 2 meters to the highest elevation of 3 meters above mean sea level. So this is the topography map of the proposed site. As we can see, the topography surrounding the proposed site is flat. The next part is the geology and soil. Based on the geological map shown in the slide, there are no valuable mineral resources detected in both within the proposed site and 3 km radius from the proposed site. So for climate and methodology, the proposed region generally experiences equatorial type of climate, which are warm and humid weather all year round. Malaysia faces two monsoon wind seasons, which are southwest monsoon from late May to September and the northeast monsoon from October to March. The next part is the water quality. Water quality for existing site is necessary to be known for determination of the background level of pollutions. The figure shows the DOE water quality index used to quantify the overall quality of the river based on the parameters needed. So this figure shows the national water quality standards for Malaysia. The next part is the ambient air. The descriptions of existing air quality will include the baseline level of pollutants listed in Malaysia Ambient Air Quality Standard MAAQS. So in this slide, the figure shows is the standards of MAAQS. The next part is the odor. The description of existing odor will include the baseline level of pollutants listed in specific pollutants, such as hydrogen sulfide, which is the primary pollutant. For this table, it shows the physiological response of the hydrogen sulfide concentration. Since there is no specific guidelines on hydrogen sulfide level in Malaysia, the measured concentration is compared with the overseas standards, which are listed as below. The first one is the Alberta Ambient Air Quality Objectives, which is 14 microgram per meter cube and 1 hour average. The next one is the New Zealand Ambient Air Quality Guidelines, which is 7 microgram per meter cube and 1 hour average. The last one is the WHO Ambient Air Quality Guidelines, which is also 7 microgram per meter cube, but it is 30 minutes average. So for the noise level, collection of noise level for existing environment is also necessary during baseline study. For noise level, there is no specific regulation, but for the noise level limit is governed by the DOE planning guidelines for environmental noise limits and control, as shown in the figure above. So we are now going into the next part, which is the biological environment. For the proposed site, it is located in the area near urban area which presents of flora but insignificant presence of fauna. The proposed site is selected to be an empty area with forests and near the riverside. For the next is the social, economic, and human environment. For the proposed site chosen, the area is currently undeveloped, which is still full of trees. The proposed site may be developed into residential or commercial area in the future as the population increases day by day. And there are 3 schools nearby the area. From site observation, the local population can be categorized mainly into the middle income category, judging from the type of surrounding properties, industrial area, and business activities taking place. The sources of the income for the local population can be prejudged as mainly wage earning, which is working in the industrial and commercial sectors, such as schools, factories, restaurants, and cafeteria. Proposed development will need the supply of utilities for the consumption of its residential area. So this is all for the existing environment.
Evaluation of impacts. One of the first impacts of the SCP is odor and air pollution. Gases such as sulfur dioxide and nitrogen dioxide will be released from activities such as transportation and construction and cause air pollution. Also, the sewage consists of a high concentration of sulfide that causes a release of bad odors and create a corrosive environment. The gas from the sewage also do not get purified before being released due to poor design and will cause odors and air pollution. Next, the impact is soil erosion. Excessive quantities of sediments are derived from soil erosion as runoff builds up rapidly to a peak and then diminish. Also, the increased sedimentation from soil erosion will cause water pollution and clog waterways. Also, one of the impacts is health. STP can cause mosquito breeding and diseases transmitted by mosquitoes such as dengue. Also, the inhalation of gases such as hydrogen sulfide can cause irritation to the eyes and respiratory system. The sewage effluent also contains pathogenic bacteria and viruses that affects the health. The noise and vibration from activities and machinery also causes noise pollution and irritation. Furthermore, one of the impacts is waste management. Activities such as maintenance of machinery, produce waste products such as hydraulic oil that causes water contamination and pollution. The sludge, which consists of pathogens and bacteria, will cause environmental pollution if leached during the storage of dewatered sludge and disposal to landfill process. Also, road traffic. The mobilization of construction will cause disruption to traffic. Furthermore, ingress and egress of construction vehicles can become a hazard to other road users. Furthermore, the increase of volume of vehicles will cause congestion and affect the safety of the other road users. Also, one of the impacts is socio-economic. Contamination of fisheries by substances such as mercury will cause closure of industries and fish stock decline. The commercial fishing industry will be affected, which will result in a massive income and employment loss. Then, quantitative risk. Accidents happen when STP is not properly maintained. The system and process failures will cause the treatment process to be inefficient. Therefore, poorly treated wastewater will cause pollution to the surrounding environment. So next, for the mitigation measures for the impacts caused by the STP. The first one is proper design. The STP must be designed to meet Standard A of Environment Quality Sewage Regulations 2009. This means that it must include odor removal system to avoid odor and air pollution. It must also include UV disinfection units instead of traditional chlorine-based disinfectants to avoid environmental pollution. In addition, it must include enclosed box for equipment and machinery to avoid noise pollution. Next, competent workers. The STP must have at least 2 highly qualified and competent workers per shift to operate the STP according to the DOE. The workers must conduct performance monitoring at a regular basis to ensure optimal performance of every unit process used in STP. Next, the mitigation measure is sludge handling. The STP must have a well-designed sludge dewatering facility to reduce the sludge volume and mass. A sludge dewatering unit can reduce the hazard of sludge produced, and the sludge can be safely disposed at the landfill. Also, the dry sludge must be properly stored to prevent any leakage into surrounding environment. Next, the mitigation measures for soil erosion. The STP should implement land-disturbing pollution prevention and mitigation measures. By implementing this, the soil erosion and sedimentation can be minimized and water pollution can be prevented. Next, for the mitigation of health impacts. The STP should implement health impact assessment. This can help identify the risk of communicable diseases due to water pollution and improper management of the area. It could also assess the health impacts of STP to nearby residents and provide treatment and changes. Finally, for the socio-economic impacts, the mitigation measures include to conduct socio-economic studies to understand the impacts of the project activities on nearby residents. The surrounding community should be engaged with regards to land acquisition and relocation to minimize the adverse impacts and ensure the adequate support and fair compensation. Also, the provision of new employment opportunities should be provided to nearby residents.
Now we move on to the last part, which is the conclusion. Based on the entitled project, a new sewage treatment plant of Semarang Petrojaya Kuching, extended aeration activated EAAS system will be used as the new sewage treatment plant. The population equivalent PE calculation for a new sewage treatment plant has been proposed to be around 15,513 PE. EAAS system have an advantage that sludge has a longer life and higher durability, making the process stable and easy to operate. Lastly, EAAS system also produce less sludge than other systems because the sludge is older and does not require further digestion, reducing sludge treatment costs. EAAS also has a lower cost compared to other systems. That's all from us. Thank you.